Let's talk about decision trees and overfitting. So with the exception of the samples that have the exact same data, we're always going to get 100% accuracy, right? And so that should give us some concern about overfitting. So let's see how bad things could get by separating our data into a training set and a testing set. So we'll use 110 training points, and then we'll use 40 testing points. And the performance that we get on the test data will give us an idea about how well our decision tree will generalize. Okay, so we're going to train our training data and our testing data, and we're going to just split into 110 training points and 40 testing points. All right, so here we can compare our model trained on two different numbers of training points. So training on 110, and then we'll also train it on 150 data points, and then see how well we do on the testing. Okay, so what we can see here on the left, we have training on all 150 points, and then on the right, we can see training on 110 points, and we can see the decision trees that result by looking at the picture visually. And we can see that there are some similarities, but there are also some significant differences. So what are some examples of some of the differences? Well, we can see on the left that it looks like there's a decision tree formed around the petal length being less than 2 point something, right? So there's a big blue vertical bar to the left. Whereas if we look on the right and the training on 110 points, we can see that instead there was a split of a horizontal blue bar at around, 0.75 on petal width, okay? So now let's see what our performance is going to be. So again, on the left, we have trained on 110, and on the right, we have our test set for the results. And again, we can see that, so the decision tree obviously is the same because we're using the same decision tree on training as we are on testing. That's the whole point. But what we see on the training set is that we get 99% accuracy. There actually are two overlapping points. But when we look on the test set, our accuracy drops. Right? It drops to 95%. And if you look, you can see that in that thin orange bar, there's a green point. And similarly, just above in the horizontal green bar, you can see that there's an orange point. So misclassification is occurring, and that's yielding less accuracy on our test set. And so that's telling us that, there may be some overfitting going on here. So we could include more features, right? That's one way we could separate out those points that are overlapping in our training set. So we could include both the petal, as we've been using, and the sepal measurements. And then we'll train our decision tree on all four columns of our data. So our petal length, our petal width, our sepal length, and our sepal width. Okay, so we're going to call this model 4D 110, all right, because we're going to train on 110 training points with all four columns. And we end up with 100% accuracy. So there's no overlapping data points when we look in all four dimensions. But we get 95% accuracy on the test set. Now, why am I not showing you that in pictures? Well, because it's not very easy to visualize things in 4 dimensions. And so having a prediction space that is 4-dimensional means we just can't look at it. But what we could do instead is we could look at visualizations of the tree themselves. So again, here we have our visualization using GraphViz of our trees. On the left, we have our 2-dimensional trained on 150 points. And on the right, we have our 4-dimensional trained on 110 points. So what's different about these two models? Where do we see a difference? Right? Well, the models are actually quite similar. Right? The 4D 110 is only using 110 samples, and the decision rules are almost identical except for the sepal width. We use it exactly once. right? So remember we had that petal length less than 4.85, and that yielded, and we couldn't separate out, right? And so we ended up with a terminal point below that that did not separate out the different classes. So now we use the sepal width to actually separate out the classes. So sepal width less than or equal to 3.1. On the left, we have virginica, and on the right, we have versicolor, right? And so it would seem that the model should be better, right? Because it gets actually 100% on our training set. It's able to fully differentiate all of the training instances. But in both cases, we end up with 95% accuracy on our test set, right? And so we need more data on our training side, and we need to look at more data on our testing side. But it's looking like we're having overfitting, even when we add all 4 dimensions. Now, one of the other things also to consider is that we're only actually using the sepal width. We never the model never uses the sepal length to differentiate between the different classes. So now let's just look instead at the sepal data. So before we tried just building a model on petal width and petal length. So let's try doing the same thing but with the sepal. So first let's plot our flowers in sepal space. So here we can see the 3 different classes in blue, orange, and green plotted with sepal length on the x-axis and sepal width on the y-axis. And what do you notice when you look at that? Well, the first thing you notice is that there's a tremendous overlap between the green and orange dots. And that should give you cause to stop and wonder, is this going to be a good set of features to use to differentiate the 3 flowers? The blue dots, they're relatively separated away, but the orange and green are not. So let's see what happens if we actually tried to train a decision tree on this data. Well, when we train on 110 and or 150 points, we're going to get decision boundaries that look like what we see below in this figure, right? And what you see is chaos, right? The decision boundaries are really erratic, right? The fact that there are lots of overlapping points means that we're only going to get 93% accuracy on the training set, and we know we're going to only do worse on the test set. But look at this. There's little islands of green and little islands or regions of orange, and they're all sort of intermingled. So it's really just chaos. And of course, if we actually do try testing it, we're going to see that the performance is going to be poor, right? So we only get 70% accuracy. So only 28 out of 40 predictions are actually correct. So the complex decision boundary we have here, if we also look at it as a tree, we end up with an incredibly complicated tree, right? And this is just because we're just overfitting to the data. The algorithm is trying to make sure that every point is correctly classified in the training data set. And because the training data set contains a lot of overlaps and contains a lot of overlaps between the regions, we're going to end up with all of these little islands and all of these weird decision rules that just aren't going to generalize when we look at our broader data set, our testing data set. And so the next thing we'll look at is some strategies for trying to prevent this type of overfitting.